Hello everyone and welcome to today's online lecture. My name is Daniel Choi and I will be guiding you through time post CPM critical math method. In this session we will cover a few particular questions related with time post CPM. The aim is to help you understand how you can solve the questions using the concept. Let's get started. Question number 1. Below are the data for the time post CPM scheduling model. The time is in days and the costs include both direct and indirect costs. If you crash this project to reduce the total time by 1 day, what is the total time of the project and total costs? What is time post CPM scheduling model? First of all, let us define CPM. CPM means critical path method. It identifies the sequence of tasks determining minimum completion time for a project. That sequence is called critical path. In this method, there are two words that matter: minimum and completion. So let us consider from this table how to incorporate both duration and cost of project activities to optimize schedule at the lowest cost. We will build a network first. Path 1 is taking the path of A, B, D, and E in its order. It takes total 13 days. And path 2, it takes A, C, D, and E. The first path takes 13 days and path 2 takes 12 days. What is critical path? Critical path is path 1 because it takes longer but is still needed and critical to get this project finished. With only path 2, it cannot finish or complete this project, so critical path is 13 days. That is the minimum days needed, and then path 2 will have 1 day slack. So you can start 1 day late or it can finish 1 day early then when path 1 is done. Total cost is, because we need all 5 activities, $1,900. So the question here is asking to reduce the total time by 1 day. So we have options to choose to crash. Which one would you choose? Activity B is no crash possible because by crashing you cannot reduce even 1 day. So A, C, D, and E can crash and then reduce by 1 day. But which one would you choose? You would want to pay the least, right? The marginal cost of crashing is at activity A, $200, and activity C, $300, and activity D, $100, and activity E, $500. So we will choose activity D, as David, to reduce 1 day. So the normal cost and additional crash costs added will give us a total cost. Let us think about the duration. Normally, critical path requires 13 days, right? And then reduce 1 day, then total time will be 12 days. And then cost, normally $1,900, but by crashing, we spent $100 more. So it would be $2,000. So the answer is B. Total time is 12 days. Total cost is $2,000. Next, the question number 2. You have arrived at the optimal solution using time post CPM scheduling model. When it had happened. Optimal solution in time post CPM is to find the lowest point on the total cost curve. Total cost curve in this graph is in color gray. So project total cost is direct plus indirect costs. And what this exhibit suggests is that direct costs, when it takes shorter amount of time, the cost will be higher. And indirect costs, the longer the schedule, the higher the cost. So direct costs have to do with crashing and putting more people, and then adding the overtime to reduce the duration of the project. And then indirect costs, it basically does not change as you see from the blue line, but the longer it takes, because of the overhead and then utility costs and etc., the cost will be added. So what we can identify from this this and then optimal solution is we can identify the minimum total cost. So that description matches to choice D, when total cost is minimum. That is the optimal solution that time cost CPM aims. Next, question 3. You have just used the network planning model and found the critical path length is 20 days and the variance of the critical path is 16 days. The probability that project will be completed in 22 days or less is equal to 2 decimal accuracy. So here we need to treat the critical path duration as normal distribution. There are two elements here, mu and squared sigma. The given is the critical path length, which is 20 days. If we treat that as the mean, mu equal 20 days, and another given one is variance, squared sigma equals 16, because variance of the critical path is 16 days. So probability that project will be completed in 2 days. So what is sigma here? That is loaded price of 16, so it's going to be 4 days. So 22 days is 20 days as the mean plus 0.5 sigma, half sigma. So we need to look for the value there, 0.50, which you can find from Z table, 0.69915. It is located to the right from the mean, because we are given 22 days, which is longer than the mean. So the probability to finish this within 22 days is 0.69. So the answer is D. So here's the summary for what we have learned over the solutions of 3 questions related with time cost CPM. CPM's main goal is to identify critical path, and critical path is sequence of tasks determining the minimum completion time for project. Critical path concept, importance of it is minimum and completion, and it works as the mean duration, the average, and defines the normal cost. Crash reduces the project duration, but it will add the cost. Total time is critical path duration minus crash time that we wanted to reduce. Total cost is normal cost plus added cost due to crash. Duration probability, when the critical path duration is located in the right in the middle as the average, in other words mean, plus minus sigma. To find the specific value, we can use the G table. An optimal solution of like CPM is the lowest point on the total cost curve. Total cost is the direct plus indirect cost. Crash increases indirect cost to reduce the spent time by adding more labor or paying overtime. And as for indirect costs, a longer project than expected can also increase it. So thank you for your attention and engagement throughout the session. Please review this provided materials and feel free to reach out with any questions about this. Thank you for your time and have a good day.